For 76 years, we thought we knew what Pluto was. We looked at the blurry, pixelated dots in our telescopes and assumed it was just a frozen, dead mistake at the edge of the map, a cosmic leftover. We were so sure of its irrelevance that in 2006, the scientific community stripped it of its title, declaring it unworthy of being a planet. We decided to write Pluto off, but the universe has a sense of irony, because in that exact same year, the year Pluto was demoted, a rocket screamed away from Launch Pad 41 in Florida, carrying a probe called New Horizons. Its mission was a desperate gamble, to cross 3 billion miles of void to catch a fleeting glimpse of the outcast. What that probe found 9 years later didn't just contradict our textbooks, it humiliated them. We expected a cratered gray corpse. Instead, New Horizons beamed back an image of a world that is geologically alive, painted in impossible colors and beating with a heart of nitrogen ice. The people in charge were wrong. We were all wrong. And the reality of what lies at the edge of our solar system is far more terrifying and beautiful than anyone dared to imagine. To understand why this discovery was such a shock, you have to understand the sheer arrogance of how we used to define the solar system. For a long time, astronomy was a chaotic game of find it and name it. Back in the 1800s, there were technically 20 planets in our solar system, because every time someone with a telescope saw a new chunk of rock, they added it to the list. It was a mess. Order had to be imposed. By the 1930s, we had whittled it down, but we were still hunting for a ghost, a hypothetical planet X that was supposedly messing with the orbits of Neptune and Uranus. Enter Clyde Tombaugh, a self-taught astronomer who spent 10 grueling months staring at a blink comparator, flipping back and forth between photos of the night sky, looking for a single moving dot among millions of static stars. He found it, a faint, lonely light drifting in the dark. It fit the criteria of the time. It orbited the sun, and it seemed to be alone. For decades, that was enough. Pluto was the 9th rock, but as our technology improved, the darkness around Pluto began to clear, and we realized it wasn't alone at all. Pluto wasn't a lonely outpost. It was the gateway to a massive graveyard. We call it the Kuiper Belt now, a vast ring of debris encircling the solar system, filled with the leftovers of planetary formation. It's the solar system's junkyard. And when we realized Pluto was just one drifting iceberg in a sea of millions, the International Astronomical Union stepped in. In 2006, they rewrote the rules. To be a planet, you had to be a master of your domain. You had to have enough gravity to clear your orbit, sucking up or ejecting all the debris in your path. Pluto failed the test. It is simply too small to clean up the Kuiper Belt. And just like that, it was demoted. But while the academics were arguing over definitions, the engineers at Johns Hopkins were racing against time. They had built New Horizons, a probe the size of a piano, and strapped it to the most powerful rocket available, an Atlas V with 5 solid rocket boosters. They needed speed. Pluto is so far away that light itself takes over 4 hours to get there. New Horizons didn't just launch, it escaped. It crossed the orbit of the moon in just 9 hours, a trip that took the Apollo astronauts 3 days. It moved so fast that it reached Jupiter in a single year, using the giant planet's gravity as a slingshot to fling itself into the outer dark. And then it waited. For 8 silent years, it coasted through the emptiness. When it finally opened its eyes in 2015, the data it sent back changed everything we know about how planets die, or rather, how they refuse to. The first thing that captivated the world was the heart, a massive, pale, heart-shaped region dominating the southern hemisphere. It looks peaceful, poetic even, but geographically, it is a violent engine. The western lobe of this heart, known as Sputnik Planitia, is a plain of frozen nitrogen about the size of Texas. But look closer. There are no craters here. In the brutal shooting gallery of the Kuiper Belt, everything gets hit. If a surface has no craters, it means it's young. It means the surface is being recycled. This isn't solid ground. It's a slow-motion ocean. The temperature on Pluto hovers around minus 380 degrees Fahrenheit. It is so cold that water ice turns into rock, harder than granite, capable of forming mountains. But nitrogen? At these temperatures, nitrogen becomes a slushy, viscous solid. New Horizons revealed that this heart is beating. Heat from deep inside Pluto is rising up, causing the nitrogen ice to bubble like a cosmic lava lamp. Huge cells of ice, miles wide, well up from the depths, cool down on the surface, and sink back down again. This creates a surface of shifting polygons, erasing any craters that might form. It is a surface in constant motion, churning and and flowing, driven by a heat source that, by all conventional physics, shouldn't exist. Small worlds are supposed to cool off fast. Pluto should have frozen solid billions of years ago. So where's the heat coming from? Part of the answer might lie in the sky. If you stood on Sputnik Planitia and looked up, you wouldn't see a black void. You would see a blue haze. Pluto has an atmosphere. It's thin, about 1,000,000 times thinner than Earth's, but it's there. As the nitrogen ice sublimates, turning directly from solid to gas, it rises up and creates layers of distinct blue fog. But there is something sinister in that air. When sunlight hits the methane in Pluto's atmosphere, it triggers a chemical reaction that creates complex organic compounds called tholins. These molecules grow heavy and rain down out of the sky, but they aren't white like snow. They are a deep blood red. This is what created the Cthulhu macula, that dark reddish stain spreading out from the side of the heart. It's a region coated in radioactive smog fallout that has been accumulating for billions of years. It paints a portrait of a world that is chemically active, creating the building blocks of life in a freezer. And if the shifting ice and red snow weren't enough to convince you that Pluto is alive, New Horizons found the smoking gun, right Mons. It is a mountain vast enough to swallow a city, spanning 90 miles across and rising 2.5 miles into the sky. But it doesn't look like a mountain on Earth. It has a deep depression in the center. It's a volcano, but it doesn't spew magma. It erupts with a slushy cryo-lava made of water, methane, and ammonia. The existence of cryovolcanoes implies that somewhere beneath that frozen crust, there is a liquid ocean, a layer of water kept warm by a radioactive core, insulating the surface from the fires below. We see this on the moons of Jupiter and Saturn, where the massive gravity of gas giants kneads the moons like dough, creating heat. But Pluto is out there alone. It has no giant master to warm it. It is generating this heat all by itself, defying our models of thermal decay. Well, I say alone, but that's not entirely true. And this might be the wildest part of the Pluto story. Pluto has a companion, Charon. Charon is usually called a moon, but that word feels insufficient. Charon is half the size of Pluto. They are so close in mass that Pluto doesn't technically orbit the sun directly. The two of them orbit a point in empty space between them, a barycenter. They are a binary system, a double planet spinning in the dark. They are locked in a gravitational embrace so tight that they are tidally locked. The same side of Charon always faces Pluto, and the same side of Pluto always faces Charon. If you lived on the far side of Pluto, you would live your entire life never knowing a moon existed. If you lived on the near side, Charon would hang motionless in the sky, a monumental anchor, never rising and never setting. It is likely that Charon is the result of a massive collision in the ancient past, a crash that didn't destroy Pluto but gave it a partner. The energy of their dance, the stress of their gravity pulling on one another might help explain the heat that keeps Pluto's heart beating. New Horizons flew past Pluto at 36,000 miles per hour. It couldn't stop. It was moving too fast. It had just a few days of close observation before it sailed past, heading deeper into the unknown. The images we have, the high-resolution maps of the glaciers, the volcanoes, the haze layers, are likely the only close-up images of Pluto we will see in our lifetime. There is no sequel planned. No orbiter is being built. We went, we saw, and we left. But in that brief flyby, Pluto taught us a lesson in humility. We tried to categorize the solar system into neat little boxes: planet, moon, asteroid, junk. We tried to define Pluto by what it wasn't. We said it wasn't big enough. We said it wasn't clear enough. We said it was just a rock in a belt. Pluto didn't care. While we were debating its status, it was out there churning nitrogen oceans, building ice volcanoes, and painting its surface with organic rain. It turns out that the universe is far more complex than our definitions allow. Pluto might be the king of the Kuiper Belt, or a dwarf planet, or a trans-Neptunian object. The label doesn't matter. What matters is that even in the coldest, darkest corners of the map, there are worlds that are vibrant, active, and alive. We just have to be brave enough to go look. New Horizons is currently billions of miles past Pluto, its nuclear battery slowly dying as it drifts into interstellar space. It will never return to Earth, but it completed its mission. It proved that we underestimated the solar system. If you want to keep exploring the strange reality of our universe, from the depths of the ocean to the edge of the stars, make sure you're subscribed. There are plenty of mysteries left to solve, and we're just getting started.